students, let us move to our new topic, that is Introduction to Phytochemistry. In this technique you have to get an idea regarding methods of extraction, application of latest techniques like spectroscopy, chromatography and electrophoresis in the isolation, purification and identification of crude drugs. നിങ്ങൾ ഫെമിലിയർ ആയിട്ടുള്ള ടേംസ് ആവും ഇത്. സ്പെക്ട്രോസ്കോപ്പി, ക്രോമാറ്റോഗ്രാഫി, ഇലക്ട്രോഫോറസിസ് ഇതെല്ലാം നിങ്ങൾ കേട്ട് നല്ല ഫെമിലിയർ ആയിരിക്കും. ആൻഡ് ദീസ് ടെക്നിക്സ് ആർ ഇവോൾവ്ഡ് ഇൻ ദിസ് ഫൈറ്റോകെമിസ്ട്രി. Phytochemistry means the chemistry of phytoconstituents. That is, in this technique mainly the extraction, separation of constituents, their isolation, purification, identification of constituents, these all techniques are possible. So among that, the most important one of the most important term is chromatography. So chromatography, that is a process. So chromatography means it is a process for separating mixture of components into individual components. How we can separate it? By using a stationary phase and a mobile phase. So we are having a group of compounds. We have to separate the group of components into individual by using a stationary phase and a mobile phase. That technique is known as chromatography. Here I have represented one image. In this you can see primary colors and secondary colors. Primary colors are red, yellow, blue, and this red and yellow join together to produce orange, then green color. That from yellow and blue, violet is derived from red and blue. So if our purpose is to separate this orange color that into red and yellow, this technique is possible by using chromatography. That is simple example for this chromatographic technique, that is for separating mixture of these components into individual components by using a stationary phase and a mobile phase. So example, in case of green color, if we have to separate the yellow and blue color from this green color, we can move to chromatographic technique. So separation of mixture of components into individual components by using a stationary phase and a mobile phase, that is chromatography. And this chromatographic methods procedure originated by Sweat in 1944, and then various activities related to chromatography were carried out. Then Constant, Gordon and Martin introduced the method of partition chromatography using a strip of filter paper for the separation of amino acid mixture. First, this technique was carried out by Sweat in 1944. Sweat carry out ചെയ്തത് ഒരു ക്രോമാറ്റോഗ്രാഫിക് സെപ്പറേഷൻ ആയിരുന്നു. അതായത് ക്ലോറോഫിലിനെ സെപ്പറേറ്റ് ചെയ്യാൻ നോക്കി. ഒരു ലീഫ് ഗ്രൈൻഡ് ചെയ്തിട്ട് ആ ലീഫ് ഗ്രൈൻഡിൽ നിന്ന് കാൽസ്യം കാർബണേറ്റ് വെച്ചിട്ട് അതിലെ ക്ലോറോഫിലിനെ സെപ്പറേറ്റ് ചെയ്യാൻ നോക്കി. ആ എക്സ്പെരിമെൻ്റ് ആയിരുന്നു ഫസ്റ്റ് ക്യാരി ഔട്ട് ചെയ്ത്. അതിൽ കുറേ ഡ്രോബാക്സ് ഉണ്ടായിരുന്നു. പിന്നെ കുറേ ആൾക്കാർ അതിൽ വർക്ക് ഔട്ട് ചെയ്തു. ഇങ്ങനെ പിന്നെയുള്ള ഒരു നല്ലൊരു ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള ഡെവലപ്മെൻ്റ് ആയിരുന്നു ഫിൽട്ടർ പേപ്പർ വെച്ചിട്ട് സെപ്പറേറ്റ് ചെയ്യുന്നത്, അമിനോ ആസിഡ് മിക്സ്ചറിനെ സെപ്പറേറ്റ് ചെയ്യുന്നത്. Then next, so we have to separate the mixture of components into individual components, that is by using a stationary phase and a mobile phase. So what is a stationary phase and a mobile phase? Stationary phase means, what is stationary? That stands. Mobile phase means that will be able to move. So stationary, not able to move, that remains in one place, and the mobile phase that will be able to move. So depending upon the nature of the substances, usually solids that are unable to move from one place to another place, that is stationary phase. So here solids or liquids also may be considered as a stationary phase, and mobile phase, fluids or gas that will be able to move from one place to another place. So that are example for mobile phases. So stationary phase means there is a phase of fixed bed or large surface area. Phase of fixed bed or large surface area. And these are porous or finely divided solids or liquid that has been coated as thin layer on an inert support material. Usually these are porous or finely divided solids, and sometimes that may be liquids. In such cases, liquid has been coated as a thin layer on an inert support material. In this image, you can clearly see that stationary phase and mobile phase. That is, light blue colored is marked as mobile phase, and white color rounds are representing the stationary phase. So here they are representing the stationary phase as solid substance and mobile phase as liquid. So stationary phase are fixed over here. Mobile phase will be able to move from the above portion to the below, that is from top to bottom. So mobile phase are able to move and stationary phase are fixed in nature. So stationary phase are fixed bed or the having large surface area, and these are usually solids, porous or finely divided solids or liquid, and that has been coated as thin layer on an inert support material. In case of liquids, that will not be able to stand as such, so we have to provide one support material. So usually that liquids are coated as thin layer on an inert support material, and that's shown over here. This is example for paper chromatography. Here in paper chromatography, we are using one filter paper named as Watsman filter paper for separating mixture of components. So here they are representing this as ink spot as the sample. So they have spotted one ink spot over this Watsman filter paper, and their purpose was to separate this spot into individual components, that color, ink color into individual colors. So what they have done means, they have spotted that on the filter paper, and that was dipped in the mobile phase. Here the mobile phase is liquid. So that is spotted over the filter paper and allowed to move. What happens? Here you can clearly see the different colors. So in case of this paper chromatography, the mobile phase is a liquid, that is the liquid or moisture which is trapped over this paper. So here stationary phase is liquid. Stationary phase is liquid and mobile phase is also liquid. Reason is, here the stationary phase is a liquid, that is the moisture which is absorbed by the cellulose present in that Watsman filter paper, and mobile phase is any hydrophilic or hydrophobic mixture solvents. So this is the stationary phase. And next one is mobile phase. Mobile phase is fluid or gas phase which moves through or over the surface. Fluids or gas phase which moves through or over surface, and this may be pure liquid or solid. This may be pure liquid or mixture of solution, or it may be gas or mixture of gases. That means usually mobile phases may be liquid or gas. That may be individual pure liquid or pure gas or mixture of solutions or mixture of gases. And the process of desorption is known as elution, and the solution obtained is called as eluate. These are the common terms used in this chromatography technique. Elution, we have to elute the substance. So process of desorption, separation and elution, elute ചെയ്തെടുക്കുക. Solution, and the solution obtained by this elution techniques are known as eluate. So these are the common terms used in paper chromatography: stationary phase, mobile phase, elution, eluate, etc. So stationary phase means that a phase of fixed bed or large surface area. These are porous, finely divided solid or liquid. And in case of liquids that are not able to stand as such, so they are usually coated over a solid inert phase. And mobile phase is fluid or gas phase which moves through or over surface. Next about the classification of chromatography. This is one more important topic. This first type of classification is based upon the principle of separation. They are first classified based upon the principle of separation, and based upon the principle of separation they are mainly classified into two as adsorption chromatography, It's not absorption, AD. Not the point, it is AD, adsorption, not AB. Absorption, what's the difference between adsorption and adsorption? Adsorption means there is a surface phenomena. Adsorb cheyyana parna muകളിൽ മാത്രമേ absorb cheyyana parna that moves inside too. So this is a surface phenomena, adsorption chromatography. So based upon the principle of separation, chromatography classified into two as adsorption chromatography and partition chromatography. First we can have discussion regarding adsorption chromatography. For understanding, an image is represented over here. This is representing adsorption chromatography, that is the substances are adsorbed over the solid surface. These are the various components and that are adsorbed over this solid substance. So in adsorption chromatography, when a mixture of compounds that are adsorbate dissolved in the mobile phase, that is eluent. So adsorbate dissolved in the eluent, that means when a mixture of compounds dissolved in the mobile phase and move through the column of stationary phase, that is the adsorbent. They travel according to their relative affinities towards the stationary phase. They travel according to the relative affinities towards the stationary phase. That is adsorption principle. Is when a mixture of group of compounds are dissolved in the mobile phase. For example, water നമ്മൾ ഗ്രൂപ്പ് ഓഫ് കോമ്പൗണ്ട്സിനെ സെപ്പറേറ്റ് ഡിസോൾവ് ചെയ്തു വെച്ചേക്കുക. ഡിസോൾവ് ചെയ്തതിന് ശേഷം ഒരു സ്റ്റേഷനറി ഫേസുള്ള ഒരു മണൽ കൂടെ, ഇപ്പോൾ എക്സാമ്പിൾ ഒരു കുറേ കളേഴ്സ് നമ്മൾ വാട്ടറിൽ ഡിസോൾവ് ചെയ്തതിന് ശേഷം അതൊരു സാൻഡിലൂടെ സോയിലിലൂടെ പാസ് ചെയ്യുക, സോയിലിൽ ഒഴിച്ചു വയ്ക്കുക. അപ്പോൾ എന്തായിരിക്കും, അതിന് പല കളർ ഫോം ചെയ്തിട്ടുണ്ടാവും അല്ലേ. അതൊരു എക്സാമ്പിൾ, അഡ്സോർപ്ഷൻ ഒരു എക്സാമ്പിളാണ്. സോ വെൻ എ മിക്സ്ചർ ഓഫ് കോമ്പൗണ്ട്സ് ഡിസോൾഡ് ഇൻ ദ മൊബൈൽ ഫേസ് ആൻഡ് മൂവ് ത്രൂ എ കോളം ഓഫ് സ്റ്റേഷനറി ഫേസ്. സോ ഹിയർ ദ സ്റ്റേഷനറി ഫേസ് ഞാൻ പറഞ്ഞപ്പോൾ എക്സാമ്പിളിൽ സ്റ്റേഷനറി ഫേസ് എന്ന് പറയുന്നത് സാൻഡ് ആൻഡ് ദ സാൻഡ് ഓർ മഡ് ആൻഡ് ദ മൊബൈൽ ഫേസ് ഈസ് ദ വാട്ടർ and the components are colors. So when a mixture of compounds dissolved in the mobile phase and move through the column of a stationary phase, they travel according to the relative affinities towards the stationary phase. They move according to the relative affinities towards the stationary phase. So here the important point is relative affinity. Adsorption means based upon the affinity. The component which have more affinity towards the stationary phase that travels slower, and the component which have lesser affinity towards the stationary phase travels faster. The component which have more affinity towards the stationary phase travels slower, and less affinity towards the stationary phase travels faster. That's the main principle involved in adsorption chromatography. So mixture of components dissolved in mobile phase passed through the stationary phase, separation based upon the relative affinity, and there is if the component having more affinity towards the stationary phase, that travels slower, and lesser affinity towards the stationary phase means that travels faster. Examples are thin layer chromatography, TLC, gas solid chromatography, column chromatography, HPLC, HPTLC, etc. That is, here one stationary phase may be usually a solid substance or fixed bed, and then there will be a mobile phase that may be a gas or liquid. TLC, example thin layer chromatography. Here the thin layer plates that acts as the stationary phase, and the mobile phase may be mixture of liquids. So the liquid substances-ലാണ് നമ്മൾ കോൺസ്റ്റുവൻസിനെ ഡിസോൾവ് ചെയ്യുന്നത്. ലിക്വിഡ്സിൽ കോൺസ്റ്റുവൻറ്റ് ഡിസോൾവ് ചെയ്ത് സ്പോട്ട് ചെയ്യുന്നു. ലിക്വിഡ് മൊബൈൽ ഫേസ് മൂവ് ചെയ്യുന്നതോറും അവിടെ സെപ്പറേഷൻ നടക്കും. ദാറ്റ് ഈസ് ഡിപ്പെൻഡിങ് അപ്പോൺ ദ അഫിനിറ്റി. ദ കോമ്പണൻറ്റ് വിച്ച് ഈസ് ഹാവിങ് മോർ അഫിനിറ്റി ടുവേർഡ്സ് ദ സ്റ്റേഷനറി ഫേസ്, സിലിക്ക ജെല്ലാണ് അവിടെ യൂസ് ചെയ്യുന്നത്. സിലിക്ക ജെല്ലിനോട് അഫിനിറ്റി കൂടുതലാണെങ്കിൽ ദാറ്റ് ട്രാവൽസ് സ്ലോവർ, ആൻഡ് ദ കോമ്പണൻറ്റ് വിച്ച് ഈസ് ഹാവിങ് ലെസ്സർ അഫിനിറ്റി ടുവേർഡ്സ് ദ സ്റ്റേഷനറി ഫേസ് ട്രാവൽസ് ഫാസ്റ്റർ. That is the basic concept involved in adsorption chromatography. Next one is partition chromatography. പാർട്ടീഷൻ കോഎഫിഷ്യൻറ്റ് നമ്മളെപ്പോഴും ഫെമിലിയർ ആയിട്ടുള്ള ടേം ആണല്ലേ. ലിക്വിഡ്സിൻ്റെ കേസിൽ പറയുമ്പോൾ പാർട്ടീഷൻ കോഎഫിഷ്യൻറ്റ്. ബെസ്റ്റ് എക്സാമ്പിൾ വി ആർ പാർട്ടീഷൻ കോഎഫിഷ്യൻറ്റ് പ്രിൻസിപ്പിളാണ് നമ്മൾ സെപ്പറേറ്റിംഗ് ഫണലിൽ ചെയ്യുന്നത്. സെപ്പറേറ്റിംഗ് ഫണലിൽ ഹൗ ദ സെപ്പറേഷൻ ടേക്സ് പ്ലേസ്. ഇഫ് വി ആർ പാസിംഗ് ഇപ്പോൾ ഒരു കൺസിഡർ ദർ ഇസ് എ മിക്സ്ചർ consisting of water and chloroform, and if we are adding salt into that mixture, what will happen? Salt will be first dissolving. The salt will be dissolving in the dissolving in water, not in the chloroform layer. So here they have shown one image in this consisting of a mixture of two immiscible liquids are there. They have passed one green color substance that may be usually soluble in the lower phase. So that gets separated depending upon their partition coefficient. The components are separated depending upon the partition coefficient. So when two immiscible liquids are present, a mixture of solute will be distributed according to their partition coefficient. When two mixtures of compounds are dissolved in the mobile phase and passed through a column of stationary phase, the components which is more soluble in the stationary phase travels slower, and the component which is more soluble in the mobile phase travels faster. The components which is more soluble in the mobile phase travels faster, and the component which is more soluble in the stationary phase travels slower. Thus the components are separated because of the difference in their partition coefficient, and no two components have the same partition coefficient for a particular combination of stationary phase, mobile phase and all other conditions. And in case of liquid stationary phase, a solid support is used over a thin film or coating of liquid is made which act as the stationary phase. That we explained in case of paper chromatography. In paper chromatography, the stationary phase is also a liquid, that is the moisture present, and that moisture is supported over this paper. So in case of liquid stationary phase, we have to provide one support. That should be an inert substance. So this is first type of classification based upon the principle of separation. First one as adsorption chromatography, and second one as partition chromatography. In adsorption chromatography, the separation takes place depending upon the relative affinity towards a stationary phase. The component which is having more affinity towards the stationary phase travels slower, and the component which is having less affinity towards the stationary phase travels faster. And in case of partition chromatography, the components are get separated depending upon the partition coefficient. And the component which is more soluble in the stationary phase travels slower, and the component which is more soluble in the mobile phase travels faster. Or in reverse case also you can represent, that is the component which is more soluble in the stationary phase travels slower, and the component which is less soluble in the stationary phase travels faster. We can represent in terms of stationary phase or in case of mobile phase or in both terms. ഒന്നുകിൽ സ്റ്റേഷനറി ഫേസിൽ മാത്രമായിട്ട് പറയാം, മൊബൈൽ ഫേസ് എങ്ങനെ വേണമെങ്കിലും നമുക്ക് എക്സ്പ്ലെയിൻ ചെയ്യാം. സ്റ്റേഷനറി ഫേസിൽ കൂടുതൽ സോലിബിൾ ആയിട്ടുള്ള സാധനം എന്ത് ചെയ്യും, മെല്ലെ ട്രാവൽസ് സ്ലോവർ, and the component which is less soluble in the stationary phase travels faster. Less soluble in the stationary phase means that will be more soluble in mobile phase. അപ്പോൾ mobile phase മൂവ് ചെയ്യുന്നതിൻ്റെ ഒപ്പം മൂവ് ചെയ്ത് പോകും. Thus the separation takes place. That is in case of paper chromatography. And example for paper chromatography are gas liquid chromatography, paper chromatography, column partition chromatography, etc. Column chromatography is included in both, that is in adsorption and partition. Here it is named as column partition chromatography. In case of column chromatography, usually their method of separation is based upon adsorption principle, And in case of column partition chromatography, the separation is partition chromatography. Most important example for this partition chromatography is paper chromatography. You should not get confused with the paper. Paper is a solid substance, but the moisture present in the paper acts as the stationary phase, and the mobile phase is also liquid. Hence, it is example for partition chromatography. Partition chromatography. So there is first type of classification based upon the principle of separation. Second one is based upon the nature of stationary phase and mobile phase. Depending upon the nature of stationary phase and mobile phase, they are classified as gas, solid, gas, liquid, solid, liquid, then liquid, liquid. That is depending upon the nature of the stationary phase and mobile phase. The nature of the stationary phase may be solid, mobile phase liquid. Hence it is named as gas solid chromatography. If the stationary phase is liquid and mobile phase is gas, means that is gas liquid chromatography. So in case of gas solid, example is GSC, gas solid chromatography. In case of gas and liquid, the example is gas liquid chromatography, GLC. And next one is solid liquid chromatography. That is stationary phase is solid and mobile phase is liquid. Stationary phase solid, mobile phase liquid. So example is column chromatography, TLC and HPLC. TLC and HPLC means high performance or high pressure liquid chromatography, and TLC is high thin layer chromatography. So in case of solid liquid chromatography, there is solid stationary phase, liquid mobile phase. Example is column chromatography, TLC and HPLC, and also HPTLC. A high performance thin layer chromatography is also there, HPTLC. And next one is liquid chromatography. That is both stationary phase and mobile phase. Both are liquids. Stationary phase and mobile phase both are liquids. Examples are paper partition chromatography. Paper chromatography, that is paper partition chromatography, and then column partition chromatography. These are example for liquid chromatography. So based upon the nature of the stationary phase and mobile phase, they can be classified as gas solid chromatography, gas liquid chromatography, solid liquid chromatography and liquid chromatography. Then third type of classification is based upon the mode of chromatography. Based upon mode of chromatography, they are classified mainly into two types. Based upon the mode of chromatography, they are classified into two types, as that is based upon the polarity of stationary phase and mobile phase. Depending upon the polarity of stationary phase and mobile phase, that is depending upon the non-polar and polar nature of stationary phase and mobile phase, chromatography can be classified into two, as normal phase and reverse phase. Normal phase and reverse phase. In normal phase, stationary phase is sorry, this one mistake. In normal phase, stationary phase is polar and mobile phase is non-polar. In normal phase, stationary phase is polar and mobile phase is non-polar, and in reverse phase, the stationary phase is non-polar and mobile phase is polar. So in normal phase, stationary phase is polar and mobile phase is non-polar. This has to be in reverse order. In normal phase, stationary phase is polar and mobile phase is non-polar, and in reverse phase, stationary phase is non-polar and mobile phase is polar, just opposite to each other. Normal എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ stationary phase polar, SP. Stationary phase polar and mobile phase non-polar, and in reverse phase, stationary phase is non-polar and mobile phase is polar. And in case of our pharmacy field, more common, all types of chromatography, most of the chromatographies are this reverse phase chromatography. Most widely used is reverse phase chromatography, that is stationary phase non-polar and mobile phase polar. and the normal phase chromatography that are not widely used in pharmacy field. Normal phase means stationary phase is polar and mobile phase is non-polar. So these are three types of classification of chromatography. First one is based upon the principle of separation as adsorption and partition chromatography. Adsorption based upon the relative affinity and partition based upon the partition coefficient. Second one based upon the nature of stationary phase and mobile phase as gas solid, gas liquid, solid liquid and liquid liquid. And third one based upon the mode of chromatography as normal phase and reverse phase. So this is about the introduction part of chromatography. That is what is the definition of chromatography and what are the common terms used in chromatography like stationary phase, mobile phase, elution, eluate, etc. And next, classification of chromatography. Next we can move to different types of chromatography. That first one is paper chromatography. Exam ne adhigam repeat cheyyunna oru question aanu principle involving paper chromatography. So paper chromatography, the principle of separation is partition that we already discussed. Partition chromatography, that is based upon the principle of chromatography, they are classified as adsorption and partition. In partition there we discussed about paper chromatography. The moisture which is present in the paper act as the stationary phase, so that is also liquid. Mobile phase is also liquid. Liquid chromatography, there is the partition based upon the separation based upon partition coefficient, so it is example for partition chromatography. So principle of separation is partition, and the requirements for carrying out this chromatography are there should be a stationary phase, then next one stationary phase, then next one application of sample. So to the stationary phase we have to apply sample by using an even apparatus. That commonly used one is capillary tube or micropipette. Then there should be a mobile phase. So here the moisture present in the Wattsman filter paper act as the stationary phase. Paper the moisture present in the paper act as the stationary phase. Mobile phase is liquid, and then application of sample has to be applied. Then development techniques, that is we can develop by any techniques. Various techniques are available for the development. Any development techniques can be applied. So main requirements are the stationary phase, mobile phase and sample applicator. Then development chamber, this is development chamber. First one is stationary phase. Wattsman filter papers are widely used for carrying out this paper chromatography technique. This Wattsman filter paper contains alpha and beta cellulose, pentose and soluble matter and ash. Alpha and beta cellulose, pentose and soluble matter and ash. This is like our filter paper. Filter paper പോലെയാണുള്ള പേപ്പേഴ്സ് തന്നെയാണ്, പക്ഷേ വാട്ട്സ്മാൻ ഫിൽറ്റർ പേപ്പർ ദാറ്റ് ഈസ് ഓഫ് ഹയർ ക്വാളിറ്റി ആൻഡ് that's having much thicker than our, it is not that much flexible as that of our filter paper. അത്രയും തിന്നുമല്ല, അതിനേക്കാട്ടിലും കുറച്ചും കൂടി കട്ടിയുണ്ടാവും. അതാണ് വാട്ട്സ്മാൻ ഫിൽറ്റർ പേപ്പർ. ഇങ്ങനെ റൗണ്ടായിട്ടും എടുക്കാം, സാധാരണ ഷീറ്റ്സ് ആയിട്ടും അവൈലബിൾ ആണ്. ഷീറ്റായിട്ട് നമുക്ക് സെപ്പറേറ്റ് ആയിട്ട് കട്ട് ചെയ്ത് എടുക്കാനും പറ്റും. നമ്മളുടെ പർപ്പസിനനുസരിച്ച് കട്ട് ചെയ്തെടുക്കാം. ഇത് റേഡിയൽ ക്രൊമാറ്റോഗ്രാഫി ഒക്കെ നടക്കുന്നുണ്ട്. സർക്കുലർ മാനറിലുള്ള പേപ്പർ ക്രൊമാറ്റോഗ്രാഫി ചെയ്യുമ്പോൾ യൂസ് ചെയ്യുന്നതാണ് ഇങ്ങനെയുള്ള റൗണ്ടിലുള്ളത്. അല്ലെങ്കിൽ സാധാരണ ഷീറ്റ്സ്, നമ്മുടെ ഫിൽറ്റർ പേപ്പർ പോലുള്ള ഷീറ്റ്സ് തന്നെയാണ്. ഷീറ്റ്സിൽ നമുക്ക് വേണ്ട സൈസിനനുസരിച്ച് കട്ട് ചെയ്യാം. അതാണ് നമ്മുടെ ലാബിലൊക്കെ യൂസ് ചെയ്യുന്നത്. അങ്ങനെയുള്ള ഓരോ വാട്ട്സ്മാൻ പേപ്പർ ഷീറ്റ്സാണ്. So Wattsman filter paper contains alpha and beta cellulose, pentose and soluble matter and ash. And different grades are available, and that may be Wattsman filter paper number 1, number 2, number 3, etc. And the cellulose layer in the filter paper contains moisture which act as the stationary phase. Note this point. Cellulose layer in the filter paper contains moisture which act as the stationary phase. Cellulose that have the capacity to absorb moisture, that so that upon air exposure, atmospheric exposure, that absorbs moisture, and the moisture which is present in the cellulose layer act as the stationary phase. That is the stationary phase. So the moisture present in the Wartsman filter paper act as the stationary phase. And next, application of sample. Sample dissolved in mobile phase and applied by using capillary tube or using micropipette. Only low concentrations are applied. Application of sample either by using capillary tube or by using micropipette. So first the sample should dissolve in any solvent. Usually that may be able to dissolve in our mobile phase itself, or depending upon the solubility. Example, in case of amino acids, usually the amino acid separations are carried out by using this paper chromatography. Here the samples, amino acids are dissolved in water or alcohol, any solvents which is preferred for which is showing solubility with that solvent. So with the solute, any solvent used can be preferred. Depending upon the solubility, we can select the solvent, or else we can dissolve in the mobile phase. But in case of this one, we are unable to dissolve in mobile phase. Sorry, it's possible. Mobile phase N-butanol, glacial acetic acid and water. That is the mobile phase for separating amino acids. N-butanol, glacial acetic acid and water കൂടിയുള്ള ഒരു മിക്സ്ചറാണ് യൂസ് ചെയ്യുന്നത്. ഒന്നില്ല അതിൽ ഡിസോൾവ് ചെയ്യാം, ഇല്ലെങ്കിൽ വാട്ടറോ ആൽക്കഹോളോ ഏതിലാണോ സൊല്യൂബിൾ അതിനനുസരിച്ചിട്ട് അതിൽ ഡിസോൾവ് ചെയ്യാം, സാമ്പിളിനെ ഡിസോൾവ് ചെയ്യാം. ദെൻ ദാറ്റ് സാമ്പിൾ ഈസ് അപ്ലൈഡ് ആസ് എ തിൻ സ്പോട്ട് over the paper either by using capillary tube or by using micropipette. Usually in our labs, our purpose is to separate this that is only qualitative purpose. In such cases, capillary tubes can be preferred. If the purpose is for quantitative analysis, how much quantity of amino acid is present in the that solution, that can be detected, maybe detected by using this micropipette. So for quantitative purpose, we can prefer micropipettes, or by using capillary tube also we can carry out this process. And the sample applied should be only in low concentration. Sample should apply only in low concentration. കുറച്ച് ഡൈല്യൂട്ട് ആയിട്ട് തന്നെ പ്രിപ്പയർ, ഹൈലി കോൺസെൻട്രേറ്റഡ് സൊല്യൂഷനായിട്ട് പ്രിപ്പയർ ചെയ്ത് കഴിഞ്ഞാൽ ടൈലിംഗ് നടക്കും, ക്ലിയർ ആവില്ല, ഒന്നും മനസ്സിലാവില്ല, സെപ്പറേഷനും ക്ലിയർ ആയിട്ട് നടക്കില്ല. And usually that are applied at an 45 degree angle. ഒരു 45 degree ആംഗിൾ ചെരിച്ചു വെച്ചിട്ടാണ് ഇത് നമ്മൾ കാപ്പിലർ ട്യൂബ് വെച്ചിട്ട് സ്പോട്ട് ചെയ്യുക. നെക്സ്റ്റ് വൺ ഈസ് മൊബൈൽ ഫേസ്. Mobile phase may be hydrophilic or hydrophobic mobile phase. That is mixture of hydrophilic or hydrophilic plus hydrophobic mix ചെയ്തിട്ടുള്ള mobile phase ആവാം. Any of these mixtures may be used as a mobile phase. That mobile phase is liquid substance, mixture of liquid or pure liquid. That is the mobile phase. So paper chromatography main principle of separation is partition, and the mobile phase requirements are stationary phase, then mobile phase, and sample applicator, that may be a capillary tube or micropipette. In case of stationary phase, the moisture which is present in the cellulose layer acts as the stationary phase. Sample applied by using capillary tube or micropipette, and the mobile phase is hydrophilic or hydrophobic mobile phase. Thank you. And the remaining portions we can have a discussion by tomorrow's class. That includes development techniques, then detecting or visualizing agents, detection techniques, then their applications, etc. Then the remaining types of chromatography, that is thin layer chromatography, column chromatography, HPL, TLC, HPLC, etc. That we can discuss in our next class. Okay. Thank you all.